binary tree level order traversal. Giving the root of a binary tree, return the level order traversal of its nodes values from left to right, level by level. So when we are saying level order traversal, we are talking about BFS. And what we are going to do, it says we have node 3 as the root node, then we have 9 and 20 as the second level, and then we have null and null, so we don't have anything under node 9, and then we have 15 and 7, and this is what we are going to return. We are going to return 3, 9, 20, 15 and 7. And if there is only one node, this is going to be the output, and if there is no node, it's gonna be empty. So, and it says the number of nodes can range from 0 to 2000. So let's see how we can do that. As I mentioned, we are going to use BFS. Let me write down this example here so we can use this example to write down our code. What we are going to do, we are going to say we need to have something to return as a result, and the format should be as a list. So we are going to say result is equal to an empty list. Then we are going to say if not root, if there is no node, we are going to just return the result, which is going to be an empty list. Otherwise, what we are going to do, we are going to use deck to keep each level in it, and this way we keep track of each nodes that we have at each level. So we are going to have a queue. I'm going to use deck. And what I'm going to do here, I'm going to put the roots in it to start with, and I'm going to put the level in it. So it's going to be level 1. So we're talking about this level, right? Then I'm going to say while queue, as long as queue is not empty, so it means we have nodes to traverse, right? What I'm going to do, I'm going to pop this from the queue. I'm going to say give me the node and give me the level, and I'm going to say queue dot pop from left from queue, pop from left, sorry, and then I will check if length of the result is equal to level. Why am I checking this? Because if the length of the result is equal to level, it means we have a list for that level. So let's do the example here. So result is an empty list at the beginning, right? And then we are going to put 3 and level 1 in the queue as the first entry, right? And what we are going to do, we are going to have level is 1. So we are going to check the length of the result is empty, and the level that we have is 1. Are they equal? No, they are not equal. But if they were equal, what we were going to do, we were going to the result at that index, and we were going to append the node.value in it, right? Otherwise, because it's not because we know the thing is empty, what we are going to do, we are going to say result dot append. We are going to append a list, and we are going to put the node dot val in it, right? As you see here, to begin with, this is how we are going to do it, right? So let's do if it is equal, and else we are going to do this, right? After doing that, what do we need to do? We need to see if there is a left node or there is a right node. So we are going to say if node dot left, we need to do something, and if node to dot right, we need to do something else. So what we are going to do for node dot left, we are going to say queue dot append. It's gonna be node dot left and level 1 is added because it's gonna be the next level. and for the node.write it's going to be q.append. The same thing is going to be node.write and level +1, right? And at the end we are going to return result as the answer. So let's see how it happens. So we start from the root that is given to us, which is going to be 3 and level 1, right? We check if q is not empty. No, it's not empty. We have this in it. We get the node and we get the level. Is the length of the result is 0, is equal to level 1? No, it's not. What we are going to do, we are going to append the node.value, which is going to be 3 and that value in it, and then we are going to see if so this is going to be popped from the queue. So then we are going to see if the node.left exists, which exists. We have 9 and 20, right? If node.left exists, we are going to append that. It's going to be 9, and we add 1 to the level, so it's going to be 2, and then we check if the right exists too, so we are going to add 20 and 2, right? And then we go if q is not empty. No, it's not empty. We pop from the left, so 9 and 2 will be popped. So we check if the length of result is 1 and the level is 2. Are they equal? No, they are not equal. What we are going to do, we are going to add the node.value, which is going to be 9 here, and this is going to be popped from the queue, and then we check if 9 has left or right, and as you see 9 has no left no right. And then we are going to check if q is not empty. No, it's not empty, so we pop 20 and 2. We put it as a 20 and level 2. We check if the length of result is 2 is equal to 2. Yes, it is. What we are going to do, we go to that index. Level is 2 minus 1 is going to be 1, so this is index 0, this is index 1, so it's going to be added here. So 20 will be added here, right? And this is going to be popped, and then we check if there is a left and right. Yes, there is a left, it's gonna be 3, and there is a right, it's gonna be 7 and 3, right? And the same thing is happening. We are going to add like 50 and 7 here, and that's about it. So let's run the code and see if we made any mistakes or we have any typos or anything. Okay, so it says I made a mistake here. So let's see what mistake did I do here. Oh, I forgot to add this here. Let's see. There we go. And the time complexity for this is linear because we have to traverse every single node that we have at least once, and the space complexity is linear as well because we are using this queue here. Thank you.